Hello students, today we are going to see about chapter 1 rational numbers exercise 1.1. So in this exercise we have totally 3 questions, and the first question is name the property under which multiplication used in each of the following. So we have to find out the property which they have used in these problems. So the first subdivision is minus 4 by 5 into 1, that is equal to 1 into minus 4 by 5, which is equal to minus 4 by 5. So actually we have the property, that is when we multiply any rational number, for example when we are multiplying a, okay, so when we multiply any rational number with 1, we will be getting the same rational number as a product. So any rational number which is multiplied with 1 will be getting the same rational number as the product. So this we can write it as also a into 1, we can write it as 1 into a also. Okay. So any rational number which is multiplied by 1, right, it is going to yield the same rational number as the product. Okay. So this property is nothing but multiplicative identity. Okay, so here 1 is the multiplicative identity. So when you compare this property here, so here this is the rational number minus 4 by 5. Minus 4 by 5 is multiplied with the 1, and that is also equal to 1 into minus 4 by 5, which is nothing but the same number, same rational number, that is minus 4 by 5. So the answer here 1 is the multiplicative identity. 1 is the multiplicative identity. Second problem is, here they have given minus 13 by 17 into minus 2 by 7, which is equal to minus 2 by 7 into minus 13 by 17. So it is actually resembling the commutative property. So according to the commutative property in multiplication, we can write that a into b is equal to b into a. So just we are changing the order of the numbers. Okay, so when we change the order of the numbers, it does not rechange your result. Okay, so the result will be same. So here the commutative property is used. So we can write that commutativity. Okay, and then the third problem here it is minus 19 by 29 into 29 by minus 19. So when you see this, actually here we have one number. When you multiply this number with the reciprocal of a number, okay, so this is nothing but reciprocal. Okay, so when you multiply a number with the reciprocal of a same number, okay, we will be getting always 1 as the product. Okay, so this property is nothing but multiplicative inverse. Multiplicative inverse. So when any rational number, right, it is multiplied with the reciprocal of a number, we will be getting the result as always 1. Okay, so this reciprocal which we are actually multiplying with the original number is nothing but multiplicative inverse. Okay, so coming to the second problem, tell what property allows you to compute. So actually here what they have given 1 by 3 into, within the bracket they have grouped two numbers 6 into 4 by 3, and this can be rewritten as, again within the bracket we have 1 by 3 into 6 into 4 by 3. So when you see this term and this term, actually the first number is separate, second and third number are grouped. Here first and second numbers are grouped and third number is separate. So actually it looks like a into, within the braces we have b into c, which is equal to a into b within the braces into c. This is actually associative property. So you can write that it is associativity. So in the multiplication we have this property which is nothing but associativity. Okay. And then the third problem, here the product of two rational number is always here. When you multiply two rational number, for example, I am taking like this. When you multiply two rational numbers, the product is also a rational number. So when you see this, here it is 8 by 15. Okay. You can say that the product of two rational number is always a rational number. Thank you. Thanks for watching.